That's not too bad, right? How do you set up this first guy? Yeah, exactly. Or you could do, well, it'd be 8 divided by 11. You gotta be careful. So you do 8 is what percent of 11? So that's English translating directly into mathematics. You gotta divide by 11 to get x by itself. 8 divided by 11. Yeah, exactly. So 0.72 forever. Which would be what as a percentage? 72.72 forever percent.
73.
Yeah, you can round it to 73. That's fine. If I remember, I don't always remember. That's what Math 88 students can attest to. I don't always remember what to tell you to round to. So in general, if you want to round, you should probably take it out a couple places, a couple decimal places, if I don't say. Yeah.
So you don't put the 11 as a decimal?
The 11 is not a percentage.
Okay.
The percent is the thing I don't know here.
Okay.
So at the end, I've got to change the decimal into a percentage. I don't do anything to either one of these numbers. These are my pure numbers, right? Like 8 people out of 11, like lettuce.
Okay. You just put the answer, or do you have to put the 8 over 11?
As long as you see some work happening, it's good. Yeah. Show me some kind of setup with some work. Yeah.
What I do is I divide the number by 100 and then times by the percentage.
I love it. So if you have, there's the is over of equals percent over 100. There's that method where the 8 is the is, the 11 is the of, and then you can just solve for P. Beautiful. Keep doing that. I love it. To me, though, that actually adds more complexity than what's necessary because it goes directly into mathematics from the way it's stated. But, again, I'm not saying anything bad. If you like this way, continue doing that way. It works beautifully. Nothing wrong with that one. Okay, maybe. All right. What about the second guy? How do you do that? Yeah, this is 0.07. Good. Times 540. 37. 3780. So that's the tax. Now, if I ask for like a part B, what total amount would you have to pay for this thing? Then you add it to the 540. I like it. But here I just asked for the tax. Yeah. How we doing? All right. John, your smartass level is almost equal to mine today, I tell you. Where'd you learn to be such smart? I learned it from you. No? Is that too old of a thing, really? Where'd you learn how to do drugs? I learned it from watching you, Dad. Well, here's your brain. Here's your brain on drugs. Stop it. Sorry. That was a montage of stuff. So, now here comes our most awaited section. It is here. Yes. Word problems. This is section 2.5. Yeah, that's the reaction I get. Now, if you go on to take Math 120, especially if you take it from me, 120 is the class that is a problem-solving class. So it's where you're allowed to solve a problem in almost any way you can consider. So algebra actually sometimes is the best way to solve some problems, whether you believe it or not. So this class is called algebra class. So when I ask you to solve a problem, you must apply algebraic concepts to do so. Even if you get the right answer, if you did not use algebra to get there, I must take off most points. Is everybody with me?
Yes.
Because this is algebra class. If this was problem-solving class, you would be fine, right? I just want to make that known right now, because I always have somebody get really upset. The answer's 7, I got 7. I don't care. You didn't use algebra, this is algebra class. Pretty straightforward. Okay.
2.7, right?
2.5.
2.5.
Yeah, sorry, I did 2.6 first, and then came back and did 2.425. So again, a lot of us have very different backgrounds. If you came out of Math 88, you should have done some basic word problems while you're in there. A lot of you guys have come from other places. So maybe it's been a while, or maybe you haven't done much with word problems. So I'm going to start off as nice as I can. And really, the nicest place to start is the kind of word problems that aren't really truly word problems. They're like one step away from mathematics. So what I mean by that is something like this. 2 fewer than 10 times a number is 78. What's the number? So I wouldn't even count this, but I'm going to do it since it's in this homework section, but I wouldn't even count this as a real word problem. This is just a math equation written in English. You with me? This is not a real word. Real word problem would be there's a train going somewhere and it's going this fast and somebody else is going to catch it and all this kind of crap, right? That's your real word problem. How do you translate this back into math? 2 fewer than 10 times a number. Yeah, so 10 times a number is 10x.
Minus 2
Good. 2 fewer than this would be minus 2
equals
is 78. And then you just got to solve that. Right? So this is really that translating from English to math. We've actually already looked at that a while back. This just involves including the word is to make it an equation. Not a big deal. So to solve this is really nice. Add 2. You get 80. Divide by 10. You get 8. Okay, and there's only one answer because there's only one question about a thing. Is what is the number we got? So at the end, you got to make sure you answer all the questions, right? So let's get into a real word problem. I think we should start with, let's see, a visual one if I can. Yes, here we go. Yeah, we might as well just go for it. I'm looking at number 26 on page 118. So again, I officially don't count this as part. So I want to show you how to set up a real word problem. And the mistake most students make is the assumption that we somehow are supposed to be able to set up an equation by reading through it once. And that almost always leads to the wrong equation, which of course leads to the wrong answer. That's where you tell me stuff like, you need to make this side -4 feet long. And I'm like, okay, first off, how do you do that? So you got to be careful about where your equation comes from. So number 26 says, the perimeter of the state of Wyoming is 1,280 miles. The width is 90 miles less than the length. So we're assuming that Wyoming is a perfect rectangle, by the way. Wyoming, yeah. What's up? Oh. Actually, I don't, but that's right. Perimeter of the state of Wyoming is 1,280 miles. So the perimeter is 1,280. The width is 9 miles. So before you start, actually, I shouldn't even have written that down. The very first thing you do when you read through a word problem is, what are the players involved? What are the pieces that are involved in the problem? So how many parts to this problem are there? How many players are involved in this problem? Really just 2. There's the... Nope. There's the length and the width. Now together those are going to make a perimeter, but the players involved are the length and the width. So you write that down. So the first step of a word problem, thank God, is an English step. You just write down the names of what's involved in the problem. Now I can't set up an equation using English names, at least not easily. So I want to convert this to math names. And the beauty of mathematics is it's an easier way to show the relationship between 2 things. So if I'm twice as old as you are, you could be X and I would be 2X. It's a very quick way to say, I'm twice as old as you are, right? So one of these is always going to be X, and everything else is going to be based off of that. So this says the width is 90 less than the length. So which one do I have to know first? The length. The width is 90 less than the length. The width is something to do with the length. I better know the length first.
X plus X minus X.
Careful. Don't go too far. One of them is going to be just X. And it's going to be the one that the other one depends on. So the width depends on the length. So if I call the length X, now the width is 90 less than the length. Now that I've called him x, I can call him x minus 90.
Equals.
You equal it to your perimeter?
No, we've got to be careful. A really good idea, and this is the reason why I want to start here, is a nice visual problem. Right? If you're talking about a shirt, a discounted shirt, you don't want to draw a little shirt. It's obviously not going to help. But a geometric problem, a triangle, a rectangle, you draw it and you label it. And that will save you from this mistake. This is the mistake I get. That is a mistake. Yeah, because here's the width and the length, the width and the length, so the perimeter has to be all the way around. Right, so I need 2 x's and 2 x minus 90s. Right? So it's not this. It says 90 less than the length. Yeah, 26. Cool. So the real equation should be x plus 90, not plus x minus 90. Or yes, you could write just 2x plus 2x minus 90s. Same way, right? Is that cool? Because I have 2 of these sides and 2 of those sides. Okay. And now I just got to solve that equation. And this should be the easy step. The hard step should be getting to the equation. So how do I solve this? Yeah. Then I get my terms together. I add the 180 over. 1460 divided by 4. So 365. I get there. Yeah, okay. And now is that it?
No.
So the really nice thing, now I know a lot of you guys are going to skip this step because you want to get done with your homework. So you'll get done with your homework pretty damn quick if you skip this step, but you almost will definitely have to redo it. So that's not really saving any time. The beauty of this is it helped me set the problem up, and it also helps me answer the question. 365 miles.
Squared.
No,
Oh, it's
no area. And that's just the sides, right? And this will be 365 minus 90, which is 275. Good. And how do you check your answer? What do you mean plug it in? The perimeter is supposed to be 1280. So you just take 2 of these plus 2 of these and you make sure it makes it 1280, right? So to check your work, you just make sure that these do what they're supposed to do. You guys semi with me? Now trust me, again, you skip this step, you're one of the people that will make the most mistakes. I'm not saying you will definitely make a mistake. Maybe you're really good at this shit and you don't need this step. That's awesome. But if you're not that good at this stuff, you should do this for yourself. Let's try one more example, and then I'll give you the handout with some examples. Let's try one that's not so visual. Yeah, we might as well try this problem here.
And Mr. Waller,
Yes.
battery's down.
Aw. Let's see how much spare battery I've got. Okay. Try and extend this guy's life here. Let's look at number 8. So let's see, blah, 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 blah. Okay. So the key thing about word problems is to realize you should look through a word problem at least twice. Once just to pick up what the parts are, and then again to pick up what the math stuff is. So what, in this problem, it's not that bad. How many parts are there to this problem?
Are you on page 117?
Yeah, page 117. Yeah. So this is still section 2.5.
Looking at 3 parts. Only 2 and then 1.
So I got Laura paying $219.45, including 5% tax for an all-in-one color printer. How much did the printer itself cost? So I've really just got, I'll accept 2. I've got the cost of the printer and the tax. I like it, so I'll take that. So I got the cost of the printer, and on top of that, I got to pay the tax. So I'm hoping, yes, sir.
I think, did I read it wrong? It says Laura paid $219, including 5% tax.
I like it. So the first step, I don't care about the numbers, I don't care about the math, I just care about what's involved. I've got a cost of a printer, and I've got the tax. You with me? Now I think what you're thinking about is that number is both of those together,
$219? Yeah.
right?
Yes.
Which means whatever I end up writing here, I'm going to add together to make 290. That's where my equation is going to come from.
Well, I think I thought I wanted to get the amount of the printer before the tax.
Sure, we could. But that 219 involves what? The printer plus the tax, right? So I need to have a math name for both of those things for me to be able to write an equation, right? Now which one of them is going to be just X?
Per tax.
The printer. Because then to figure out the tax, how would I figure out the tax? The tax is 5% tax, right?
Yeah.
How could I figure out that tax? I have to first know how much the printer costs, don't I? Because then I can take 5% of it. So it's really the same question. What do you need to know first? That's what X is going to be. I've got to know the cost of the printer, so that's X. Now how much tax am I going to pay? 5% of X. So how do I write that?
5% times. No, point. I mean.
0.05 times X. Cool. You guys with me? So in real life, if I had to pay 5% tax on something, I know how much the thing costs because I'm looking at it. So I would take 5% of the cost I'm looking at and add it back on. Here, I know what the end cost was. I don't know what the intermediate costs were. So whatever, I would still take 5% of the cost of the printer. It's just that I don't know the cost of the printer. So I take 5% of X because I don't know what the hell it is. So that's the whole thing about algebra. I don't know what the parts are. I don't know what their values are, but I know what they do together. And that's an equation. So now how can I set up the equation?
Equals 219.
Yeah, these two doing what to each other? Adding. So if I take the cost of the printer plus the tax, it's got to equal the $219.45 that she actually paid. This was made up of tax and printer cost. So you can see that where that equation comes from. And I'm hoping, this is again, the key to mathematics is being able to break a problem into its parts. And that's exactly what I'm trying to do for you with this format. If you realize I look through it once just to see in English what's the parts. Then I start giving math names to stuff. And I love the fact that you saw that. You thought ahead. Well, but that's what the equation is going to be. Together they make this much. That's the equation. That's how they relate to each other. And now how the hell do I solve this thing? The big mistake I get here is you get somebody tell me this is 0.06. You see why they thought that? But it's like $1 plus 5 cents. It's not 6 cents, right? So what should this be? What's 1 whole x plus 0.05x? 1.05. Because this is 1x, so it's 1.00x. I can add as many zeros as I want to. Right? We know that. So it wouldn't be fair. $1 plus 5 cents is not 6 cents. That's not fair. Right? $1 plus 5 cents is 1.05. Cool. Equals 219.45, and then I just have to divide. Somebody help me out there.
Wait, that's just like solving a normal equation where you...
Yeah, the minute you get your equation set up from how these things relate, you just solved it, right? That's why your solving equation skills have to be pretty good so that the rest of this problem is easy. It should be easy.
209.
209? Cool. So that cost of the printer was 209. I think that's all they asked me, right? How much did the calculator? How much did the printer itself cost? 209. If they would have asked me how much the tax was, I could just take 5% of that, right? What is 5% of that? Help me out. 1045. I'll bet you did. How did I get that? Because I know that these two have to add it to do that. But I mean, you should do 5% of that and then check it by adding them together to see if it is this. That's how you would check your work, right? Do they do what they're supposed to do?
Yeah, I think you wanted to ask what I'm about to ask, but I was trying to figure it out myself. I just multiplied that total, the first original total, by 0.05, and then subtracted that number from the total.
All right, so that's exactly the most common mistake I see. And it's because 219.45 came from applying 5% to a lower number. So if I take 5% of this now bigger number and subtract, I'm going to go too far down. That's the biggest mistake. So a quick little example.
Right, because I did the same thing and I ended up with the smaller number. I got 208.
Exactly, I love it.
Or 48.
So watch this. If I get my check, and let's pretend like I get $10 an hour. All right, which is actually almost 3 times more than I made in my first job. But let's pretend I got $10 an hour, and I notice that they cut my pay by 10%. So how much am I getting now? $9. So they cut $1 off. So I go in there and say, hey, what? So they say, okay, we're sorry. We'll put 10% back on. Well, that's not good. Because what's 10% of 9? 90 cents. So now I'm making $9.90, and we all know that 10 cents an hour adds up. Right? I know a lot of us should know that. So the percentages don't make any sense by themselves. It all depends on what they're based on. So when I'm adding tax, I normally take 5% of the original cost. So if I try to go backwards by taking 5% of the end price, that's never going to equal the 5% because that's 5% of a bigger number. I've got to take 5% of the original number, but the algebra is what helps me out because we don't know what the hell the original number was. So thank God we got algebra, which is good at doing this backward shit. It's really what algebra is all about. So 5% of the original cost added to the original cost is the sale price. I can never do something to the sale price to work back where the original price was. You guys kind of with me? Nothing directly. I have to do this. This is what I would do normally. So if I had a thing that cost $500 and I wanted to add 5% tax on, this is what I would do, isn't it? Right?
Yeah.
So I don't know what it is. I don't know what it was. That's exactly why I've got that setup. We do the same thing to the thing I don't know, because I don't know what it was originally, right? So I'm glad you said that, because I completely forgot. I mean, that's the most common mistake, is to apply the percentage to the end number. You can't, because it was applied to a smaller number to get there in the first place. Cool. Okay. Let me give you this. Here on one side is the updated homework. It really just has a very minor change with the test and a couple dates, and then the rest of it's the same. But on the back are 2 worked out examples of word problems. Thankfully not in my handwriting, so you can actually read it. There was the practice test. You got that one earlier? Oh shit, no. I can so not multitask. That's all right. Make sure you got a front and back. My printer has a consciousness. That's the mess with that. So So take a second, make sure you have a front and a back when you get your sheet.
Adventure time.
Yeah. On the back, I got 2 examples of word problems worked out, showing you the steps. What are the players? Which one's just X? Translate into an equation, solve it, make sure you get the whole answer, and then check your answer. So let's do one more problem. I'll see where you guys want to go from there. Yeah. Number 32 on page 118. Ooh, that's really evil, but that's good. Second angle, a triangle is 4 times the first. The third angle is 45 degrees less than the sum, where'd it go, of the other 2. Find all the angles. So first off, what's true about all the angles in a triangle?
Equal to be 180.
Yeah, no matter what triangle you draw, as long as the sides are straight, all the angles inside must make 180. Right? 180. And the reason that is, the simplest reason is, a rectangle has 90-degree angles all over, so how many total degrees in it? 4 90s is 360. And to make a triangle, you cut it in half, right? So that would make 180, right? So I know that's in the background here. I know all the angles in a triangle have to equal 180. That sounds like where my equation is going to come from, right? What players do I have in this problem?
On the first angle,
I got a first angle,
second,
angle, third angle. Use the exact same terminology they do. That was pretty easy, but sometimes I'll say one angle, the other angle, the last angle. So you say exactly that. One angle, the other angle, the last angle. Because then you can see directly where things are coming from. You with me? Don't say angle A, B, and C, because you're like, and then in the middle you're like, what the hell was B and C? It's really, it's the same language. Which one has definitely got to be X? Why the first one? Yeah, the second one depends on the first one, and the third one depends on both of them. So everything kind of somehow relates to the first angle, right? You've got to have the first angle first. So that's going to be X. It's not always the first dude is X, right? Hopefully, I can't remember. First one's not always X. It's just whatever everything else depends on, right? Now, the minute I know the first angle is X, what's the second angle?
4x.
4X. Now the third angle is 45 less than the sum of the other 2. Careful. 45 degrees less than the sum of the other 2.
X plus 4x.
So 5x minus 45 degrees.
Yeah.
They're only
Equals it.
units.
How is that 5x?
What's the sum of the other 2?
Oh, okay.
And then 45 degrees less than that.
Okay.
Is that cool? The third one is 45 less than the sum of the other 2. You guys semi with me? Yes, ma'am.
Would you say 5x minus 45 equals x?
No.
No, okay.
Because
Oh, it equals
nowhere
180.
does it say the third angle is the same as the first angle. That's what that would imply, isn't it?
So 5x minus 45 equals 180.
No.
You'd add them all equal one.
Now, again, don't feel bad. The third angle by itself can't be 180. What's 180?
Yeah.
All 3 angles together.
Yeah.
Good. So then what's 180 is x plus 4x plus this. Now what might have thrown you off is you're saying you've already got the other two angles in there, right?
Yeah,
But this is the first angle. This is the second angle. This is the third angle.
that's the formula.
Now the third angle is dependent on those two, but
Okay.
what does the 180 care about? You have to take all three angles at once. So that's why these are all three angles. Here's their math names when they add all three angles together. However you got there, when they add all three together, that makes 180. I think what might be a good idea, I think after this one, together we're going to create our own word problem. Because it's good to do that, because normally when you create your own problem, you start with the answer, and then that might help us see where things are coming from. Say again?
How do you know the 180?
It's any triangle, when you add the angles, it makes 180. It's just a fact. And not every triangle is going to have a right angle, but if I had like something like that, these still add up to be 360, so a triangle is always going to be half of something with 360, so any triangle is going to be 180. Yeah?
Is it x equals 25?
I don't know yet. So now you just got to solve this, right? So you got x4, and that's 5, 10x, add the 45, 225.
No, 13.5.
What's up? Yeah, so x equals 22.5 degrees. So the first angle is 22.5. The second angle will be
9.
4 times that, which will be 90. Is that cool? Just do 4 times 22.5.
Where'd you get the 25?
Divide by 10, right?
Oh.
So I'll move the decimal back one. And then the last angle has to be 5 times that, which will be 112.5 minus 45 is something.
67.
Thank you, 67.5. And to check yourself, you just add these 3. And thank God they do make 180. Now go with me for a second. Let's create our own word problem. Any questions on that one specifically?
Yeah, I still don't even understand where you got the 5x and the third angle.
So it says here the third angle is 45 less. So I know it's going to have minus 45 on it. 45 less than the sum of the other two. And what's the sum of the other two? 5x. Cool. That's just creating what the third angle is. And then there was some understandable confusion about, well, what's got to go in for the 180? But the 180 says you have to add all 3 angles together to make 180. Cool. So, if I had a triangle, let's say, give me a number for that angle.
63.
Height. So let's say, all right, so let's say this is 33. Let's say this is 63. What's that one gotta be? How do you figure out what that one has to be?
As is to be.
Yeah, so far I've got 96.
184.
84.
We have 180 minus 96? 84, yeah, good. Obviously not to scale. You guys with me so far?
Yeah.
Now, so to create a problem, I start with the answer and then I kind of work relationships out. So one relation I can call, let's call this one the first angle. Let's do this. Let's call this the smallest angle, middle angle, largest angle. You with me? Do you guys understand what's going on right now? We are creating our own word problem. Whenever you create your own problem, you start with the answer. And again, real life, there's not some guy up on a mountain throwing problems out. I will start with the answer 7. Go. No, there's just things happening and we make equations out of it and we solve it. We're not quite in real life, so we're going to create our own situation. What's the relation between the middle and the smallest?
30.
I love it. So one relationship between the middle and the smallest, and the most direct one is that the middle is 30 more than the smallest, right? So you can say the middle is 30 degrees more than the smallest. You with me? I could have also said, now let me see if you guys are with me on this. The middle is 3 less than twice the smallest. What's twice this? Minus 3. Do you see how they both represent the same situation?
You mean 3 more than twice?
Second?
You mean 3 more than twice?
No. Twice 33 is 66. 3 less would be 63. So I could have said the middle is 3 less than twice the smallest. It would have actually meant the same thing. You guys kind of with me?
Yes.
All right. So there's a lot of different relationships that will end up with the same numbers. But let's stick with that one. I like that one. Now, how do we do the largest one? What's the most straightforward way to do it?
12 less, double, or like 12 less than some, like the middle one.
I like it. So it's 12 degrees less than the sum of these two. I like it. So the relationship for the largest one is 12 degrees less than the sum of the two others. Two other angles. Does anybody else see a different possibility? I could do, what's 3 times this? 99 minus 15, right? So I could say the largest is 15 degrees less than 3 times the smallest. Are you guys kind of with me? A little bit? Do you see how, I mean, that's, of course, should be a little bit easier because I know the numbers. I can see how they relate. That's why algebra is hard. All I have are the relationships. I don't see the numbers. So I got to work with the relationships directly. Yeah.
So different wording with the same result, right? I mean,
Exactly. Right? Yes. So if I make my problem, if I say I have a triangle where the middle angle is 30 more than the smallest, and the largest is 12 less than the sum of the other two, it should end up with this triangle here, right? So let's try it out. So I got smallest, middle, largest. Which one's got to be just x? Yeah, the smallest one, because the middle one depends on it, and the largest one depends on both of those. So everybody somehow depends on the smallest one. He's what starts everything off. So the smallest one is x. What's the middle one?
X plus 30.
X plus 30. And the largest is 12 less than the sum of these two.
X plus 30 minus 12.
Careful, it'll be
Oh, X plus
2x plus 30 minus 12. I like it. And what are those 3 things supposed to do? Equal 180. So I use x plus 30 plus 2x plus 30 minus 12. Just step over there. There you go, John. And then you just solve that. Let's see. 2x, 4x, 60 minus 12. Is that cool? Just putting like terms together? Good. Minus 48. 4x equals 132. Then divided by 4. 33. 33. Right? I mean, that obviously it's not like a David Blaine. We knew it was 33. We started at 33, but I'm hoping this shows you something. I mean, I could have set this up entirely differently like I was doing. This one is 3 less than twice that one. It would have had a different equation, but it would have ended up with the same numbers. Because there's a lot more than just one relationship between any two numbers. What's the relationship between these two? Well, that's 5 more than that. Or it's 3 more than double this. Or it's 1 less than the cube of this. I mean, do you see how you can? There's an infinite number of freaking relationships you can come up with. Depending on which level of math you're in, you'll see more complicated relationships, right? Okay, maybe. I'm trying to give us our first early day. I don't think I'll have too many people not like that idea. Yes, sir.
I just want to make sure. To get that equation along the right, all you do is take each section of each angle. And
Yeah, each angle must add up to be 180. No matter where each of these things came from, the equation says all of them together makes 180. I like it. All right. So, go forth and try those problems out. And like I said, on Monday, I'll have the answer key for this. I have 4 practice problems, word problems on here. Yes. Anybody else need the practice test? Did everybody get that? Oh, good. Okay, gotcha. Thank you. All right. The video's up online. And now you got the internet. So you can see it. Cool. Okay. Yeah. Oh. Make sure there's a back on that. Kim. Is it Kim or Hein? That's Kim. Is there a back on it? Oh. That's the back, yeah. Oh, yeah. So you can have a copy of it. If I have any. I know I have some. There was something. There we go. Yes, exactly. Just like in the ADA class, same way.
The homework to 3.3 is due on Tuesday? To 3.
Yes, and that really kind of depends on if we make it that far on Monday.
Okay.
So on Monday we'll know exactly how much homework is due the next day.
Okay.
And the practice test. Yeah, that's just a handout. The practice test. That.
Oh, 1-4. There's 1-4.
Yeah, that's just no.
What's 2
And
times
then the practice test.
2 times 3 times 5.
Yeah, so it'd be 2 times 3 is 6, times 5 is 30. You wouldn't do 6 times 10. You only distribute if it's a plus or a minus inside. If it's all multiplication, you can multiply whatever order you want to, but there's not more than one thing to kind of distribute. There's not 2 terms. There's really just one term. Good.
What did you say? I'm sorry. Practice test is done?
Letters first.
I think the day of the test.
How do you